In Lesson 5 of Unit 3, we're going to learn how to graph square root and cube root functions. This is something that can be easily done using Desmos, the graphing utility on our Chromebooks, or on a graphing calculator. I want to show you why the graphs look the way that they do. So we'll start out with the parent function for the square root function family, and that being the square root of x. If I were to make an input-output table, I'd have something like this. Here are the x values, and then the y values, or outputs, or another way I could label that would be the f of x, the output when I plug in particular values for x. I'd start by plugging in 0 and thinking about what that would give me. Well, what's the square root of 0? Well, that's 0. So 0, 0 would be the first point on my square root function's graph. What about 1? Well, the square root of 1 is 1, so 1, 1 is going to be a point that's on our graph as well. And the next one, remember I'm plugging these in and taking the square root. So the next number I plan on plugging in is actually 4. Because when I take the square root of 4, I get 2. So 4 comma 2 would be a point on my graph as well. Next nice one to plug in would be 9, because the square root of 9 is 3. So 9, 3 is going to be a point that's on my graph as well. If I were to connect those points with a nice smooth curve, it would start at 0, 0 and look something like this with an arrow going there. Now, as far as the other part's concerned, if I were to plug in, let's say, -1, well, all of a sudden I'd take the square root of -1, which is I, which means it's imaginary. So it doesn't actually exist on a graph. So -1 doesn't actually work. You can't take the square root of -1 and graph it. Same would be true of -2, -4, anything like that. So that brings me to the idea of domain. The domain is the possible x values that I can plug into my function. I think of my function maybe like a function machine, where there's input and then there's output. Stuff goes in, something happens in here, and then out comes an output. Well, this machine is the square root of x machine. I plug things in and it spits out an output. The domain is kind of like a filter on my function machine. It's telling me these are the x values that you can safely plug into your machine. If I were to plug in any kind of a negative number, it would break my machine. So I have to filter them out and say, you know what, the only numbers that I can plug in here are x values that are greater than or equal to 0. Those are the things that I can safely plug into this function and get an output. So when I write my domain, I write it as an inequality often. So we would say x is greater than or equal to 0. On pre-calculus, you'll learn this fancy way of using this thing called interval notation, and that would look like this. If I was to describe this interval using interval notation, I would put a bracket and then 0, comma, infinity with open parentheses. This is saying that my interval, my domain, starts at 0, including 0. That's what the bracket is for, similar to the or equal to bar that goes underneath this greater than symbol. And then it extends all the way to infinity. This thing goes, starting at 0, goes forever in this direction. So I extend to infinity with the parentheses saying that it's not closed at infinity, because infinity is a concept, not a particular number. Now next, the idea of range. Well, range is the possible y values that I could get. And you'll notice that I can't get any negative numbers because of the values that I got when I plugged in 0 and following. So the output is going to start with 0 in this case. The range is going to start with 0 and be 0, and then 1, 2, 3, etc. And anything that goes from 0 and up. So I label my range as the y values. The y values that I can get here start at 0 and go up from there. So I'd say that the range is y values that are greater than or equal to 0. And again, if I were to use this fancy interval notation, it'd be the same. 0 is the first output I got based on the first input value, and it extends all the way to positive infinity. So a couple ways for you to label the domain and the range, but this would be the domain and the range for this function, the square root function.